This SOS video is on the differences and similarities with arithmetic and geometric sequences. And this is a reminder of what a geometric sequence and arithmetic sequence is. So remember, an arithmetic sequence, we add a fixed amount, the common difference, which is called D, to get to the next term. A geometric sequence, we multiply by a fixed amount. That's called the common ratio R to get to the next term. So in the first example, you're asked to determine whether the following sequence is arithmetic or geometric and what the value of either the common difference is or the common ratio. So pause the video, try to do those three problems on your own and start the video again, see how you do. Okay, so for this first one, the numbers are going down and they're going down pretty rapidly. So usually that means we're looking at a geometric sequence. But just in case you thought it was arithmetic, remember what we do to find the common difference for an arithmetic. We take any term, so I'll take 30, and we subtract the previous term, 120. And I get negative 90. If I do that with any other term and the previous term, I should still expect to get back negative 90. So let's try that. 120 minus the previous term, 480, and that gives me a different number. So I know this can't be arithmetic. Let's try geometric. Geometric, the way we find the common ratio is we take any term and we divide by the previous term. So again, I'll start with 30, divide by the previous term, 120, and I get 0.25 or 1/4. So if I do the same with another pair of terms, I should still get this same amount. So let's try that. 120 divided by 480, and I get 0.25. 480 divided by 1,920, and I still get that. So I know that this is a geometric sequence, and the common ratio is 0.25. All right. Let's take a look at the next one. So looking at this, it's going up, and it's going up pretty slowly, which usually means it's an arithmetic sequence. But let's just make sure. So I'm going to take any term, say I pick this one, 165.9, and I subtract the previous term, 163.1, and I get 2.8. If this is truly an arithmetic sequence, no matter what term I pick, if I subtract the previous term, I will still get 2.8. So let's try it with 160.3. I'm going to subtract the previous term, 157.5, and I get 2.8. And if you want to try it with one more pair, 163.1, and I subtract the previous amount, 160.3, and I also get 2.8. So I know this is an arithmetic sequence. The common difference is 2.8, which means every term that comes next, I created by adding 2.8. All right, with the last one, we're not sure what this could be. Could be arithmetic, it's going up pretty slowly, or it could be geometric. It's being multiplied by a ratio that's pretty close to 1. So let's try arithmetic first. I'll take any number, 32.67. I subtract the previous one, 29.7, and I get 2.97. If this is arithmetic, if I pick another term to start with, say 29.7, and I subtract the previous term, I should still get 2.97. And I do not. So that is definitely not arithmetic. Let's try geometric. I'll pick any term. So again, we'll start with 32.67. And I divide by the previous term, 29.7, and that's 1.1. So let's see if I get that same ratio when I pick a different pair of terms. So if I have 29.7 and I divide by the previous term, 27, I also get 1.1. So I know this is a geometric sequence, and the common ratio is 1.1. And that means to get to my next term, I would take this term and multiply it by 1.1. Well, what happens when you're asked to write the explicit rule and you don't have the first term? So if you're already given the common ratio or difference, we're going to use the inverse operation to move backwards. So instead of adding to move forwards, I would subtract that same amount to move backwards. Instead of multiplying to move forwards in a geometric sequence, I would divide by that number to move backwards. If you're given two terms, you're going to write the terms as a pair of points. You'll find the rate of change, and then you use the inverse operation with that rate of change. That would be your common difference to move backwards. So let's try it with a few questions. What's the explicit rule for the geometric sequence that has my fourth term is 20 and my common ratio is 1/4? Okay, so in order to write the explicit rule, we need the first term. So we know this is n and a sub n. We need the first term, which we don't have. We could use the second term. We still don't have that. We don't have the third term, but we do know the fourth term is equal to 20. And we do know that going forwards, we would multiply by 1/4. So instead of going forwards, multiplying by 1/4, we go backwards. We divide by 1/4. But remember, dividing by 1/4 is the same as multiplying by the reciprocal 4. So if I divide 20 by 1/4, it's the same as multiplying 20 by 4, and I get 80. And then I'm going to divide 80 by 1/4, which is the same as multiplying it by 4. I get 320. And then divide this by 1/4, which is the same as multiplying it by its reciprocal 4, and I get 1280. So now I have my first term is 1280. I have my common ratio is 1/4, and I write my explicit rule. A sub n equals my first term times my common ratio to the n minus 1 power. And it's always a good idea if you write the equation to check your answer. So let's go to y equals, and we're going to put this in so we can get our table of values. 1280 times 1/4 to the x minus 1 power. And I'm going to go to my table of values, so second graph, and I take a look, and sure enough, when x is 1, y is 1280. When x is 2, or n is 2, this is 320, and all the way to what we first started with, our fourth term was 20. So we know for sure our rule was correct. Okay, what about the explicit rule for this arithmetic sequence that has the fifth term is 17 and the ninth term is 41? They did not give us the common difference, but we can find that because if we have two terms, we're going to write the terms as a pair of points and we'll find the rate of change, which will be our common difference. So let's try this. This is 517, and this point would be 941. Okay, to find the rate of change in y over change in x, delta y over delta x, I can pick any y value. So say I pick this one, 41 minus 17. I go back to this point, 9 minus 5, and I get 24 divided by 4, which equals 6. So I know that my common difference, or D, is equal to 6. To write the explicit rule, I need to find my first term. So again, I'm going to set up my table of values. I have n and a sub n, and 1, 2, 3. Okay, the earliest term I got was 5, and this was 17. If my common difference is 6, I know going forward I would add 6. That means going backwards, I would do the inverse operation. I would subtract 6. 17 minus 6 is 11. I'm going to subtract 6 to get to this term. 11 minus 6 is 5. I subtract 6 to get to the second term. 5 minus 6 is -1. And I subtract 6 to get to this last term. -1 minus 6 is -7. So our explicit rule states that we need our first term and we need our common difference to write the rule. So a sub n is going to equal -7 plus 6 times n minus 1. Let's check that in the calculator. So you're going to go to y equals, clear whatever you have, and type this in. We have -7 plus 6 times x minus 1 in parentheses. I'm going to go to my table of values, and let's see. When x is 1, y is -7. When x is 2, y is -1. And the third value would be 5. The next one would be 11. And the fifth one would be 17. And let's make sure that the ninth one would be 41. And that is also true. So I know that my rule is correct. The last thing you're asked is to find the 21st term. So when I ask you to find the 21st term, that's the position, that's the place. So I'm telling you n is 21. And anywhere you see n, you just replace it with 21. And we can do this mentally. 21 minus 1 is 20. 20 times 6 is 120. And 120 plus a -7 is 113. So we know that our 21st term is 113. And that is how we can use information that we're given to create either a geometric explicit rule or an arithmetic explicit rule.